Let's take a simple example. Okay, so what was this? This was the example of temperature, right? And there will be a lot of components which will be having the ambient temperature, right? Similarly, I can have the normal distribution curve for pressure also, or the vehicle speed also, right? I have, for example, I have a different vehicle speeds. Then most of the time vehicle cannot be at zero, right? While running, vehicle has to move with some average speed, right? So most of the occurrences will be at average speed. Similarly, pressure, right? So what do you think? Velocity and pressure will also follow this normal distribution, right? Yes or no? Now, the challenge here is, if you want to compare these two, for example, I have one more curve here. Assume that I have one more curve, okay? Say, what would be the ambient temperature, guys? 1 atmospheric pressure, right? And what would be the ambient temperature? 35 degrees. So if I have two curves, one for temperature, the average temperature is 35 degrees, and the other one is, say, pressure curve, where the ambient temperature is, say, 1 atmospheric pressure. So don't you think it will be difficult to compare these two curves because the scales are different? Yes or no? Because we all know, if I want to write 1 atmospheric pressure in SI units, you have to write that in Pascal, right? And then pressure will become, what is, how much 1 atmospheric is equal to how many pascals? So you got it right, right? So you are writing in some other units, Harsha, I believe, but yes. So somewhere near to average, the value would be 10 power 5, right? So exact value would be the one which is mentioned by Georgi, right? But that's not the issue. Let's take 10 power 5. So don't you think the scales are different? The scales are different, right? So to bring those two different scales into one common scale, we convert all the normal distribution curves into standard normal distribution. So for example, say I have pressure curve, I have temperature curve, I have, say, velocity curve. Here, if I want to do normal distribution with average, would be somewhere around 10 power 5 pascals. For temperature, it would be 35 degrees. For velocity, it would be like, say, 45 kmph. Now, if you notice, the scale is different for all the three normal distribution, and the units are also different, right? But the most important thing is scale is different, right? So how would you compare? How would you bring? And if I want to bring all these three curves, say this curve, and this curve, and this curve, if I want to bring all these three curves into one curve, will it be possible for me? No, right? It will not be possible, right? So what's important here is to bring all those 5 which I was talking about. So I'm just showing it here. I have so many normal distributions with different colors, and I want to bring them. See the importance of this. I want to bring all those different distributions to one common scale. So for that, what I do you remember what is mu? Mu is mean, x is observation, sigma is standard deviation, right? Making sense? So what I will do, for every corresponding x value, for example, for temperature values, average temperature divided by standard deviation of temperature, I'll convert all the temperatures with z values of temperature with this formula. I'm converting my temperature column. Say, for example, I have a data set in which I have velocity, pressure, and temperature. And I know that all the three has a different scale. To bring them to a normal scale, for temperature, the scale would be different, right? For pressure, the scale would be different. For velocity, the scale would be different. So now, to compare these features, it would be really difficult. And when you do machine learning analysis, your machine learning will be dependent on your values. So for pressure, the values are very high, right? So that will influence your machine learning algorithm, and we don't want to do that. So for that reason, we convert all the different columns into one single parameter or common scale to one particular common scale, which is called as Z scores. I will generally call Z scores as Z scores. Okay. So this Z score is for temperature, it will be X of temperatures minus the average of that temperature. Temperatures, I have the value of different temperatures, and then I have the average of the temperature. I have the standard deviation of the temperature. You know, I have already explained how to calculate standard deviation, right? So once the mean and the standard deviation would be constant for temperature column. For the different values of temperature, you will get the different Z value, right? Yes or no? Right. Similarly, we do the same thing for pressure. See, for example, if the temperature values are ranging from say 0 to, say for example, from 0 to 200 degrees centigrade, and the average is say ambient temperature, the average is also ranging in the same scale. So what we are trying to do here is, let's do one simple exercise, guys. If I explain you might not be able to understand. Let's do one simple exercise. Open your Excel sheet, guys. Calculate. Let's open your Excel sheet. Let's assume you have some X value, which are say 1, 2, 3, 4. Sorry, let me write 1, 2, 3, 4, 5. And say Y value as 100, 150, 175, 200, 225. Okay. Please everyone open your Excel sheet now. Instead of temperature, pressure and velocity, I'm taking some random features or random columns here, which are X and Y here. Okay. What is the mean for this column? Can you please tell me, guys? 3, right? What is the standard deviation? So please calculate the standard deviation. How do you calculate standard deviation? There are inbuilt functions in Excel, or you can directly apply that formula which we have learned, right? X minus mu whole square divided by n under root, right? Square root of X minus mu whole square divided by n, right? So you can directly apply that formula here, but I'm directly using that function here. Okay, so let's use that function, or let's calculate, because so that you can also practice. Everyone can practice that now. So let's first calculate X minus mu, which is mean, right? What will be the value of this? X minus mu. What will be the value of this? Minus 2, minus 1, 0, 1, 2. And then X minus mean whole square, right? What will be the value of this? Minus 2 whole square. See, we don't have to do that. We have to just write this square and then drag it. So these are the square values, right? Now what is the summation of this column? Sigma, right? Summation. Summation is equal to, what is the summation of this? 10, right? So now we have calculated the summation. We have to divide that by number of observations, which is n for population, right? For the population formula, we have n, right? So in this case, 10 by 5, which is 2, right? 10 by number of observations, which is 5, which is 2. Okay, I don't know why is it taking like this, but we know that it is 2. Okay, it's still taking date. It's because it's in the date format, I believe. I have to change that format. Okay. So let me, so 2, okay. Now, standard deviation is, this is the variance, right? This is variance. So what will be standard deviation? Square root of 2, which is 1.414, right? So now we have mean, we have standard deviation also, right? Can you have, so can you guys please calculate the mean and standard deviation for this Y? Can you please quickly do it, guys? Okay, so mean is 43.1, standard deviation is 43.1, mean is 170. Okay, that was, I was wondering, how can mean be lesser than the minimum number? So mean is 170, standard deviation is 43.01. Similarly here, the mean is 3 and the standard deviation is 1.4. 414. Okay, so now let me erase all this. Now let's calculate the z value for x. Okay, now you would notice something really interesting, guys. Okay, now what is the formula for z? X minus mu by, so x minus mu, and this mu is constant, right? So I have to put $sign here. Let me just increase the font size. Why is it not increasing? I'm sorry, I'm not sure why is it not increasing, but you got the logic, right? So x minus mu divided by sigma, and the sigma is again constant value, which is this one. Okay, now if I drag it, I'll get the z values for everything, right? Okay, is everyone able to understand this? Z values for x minus mu by sigma, right? Similarly, let's do it for y. Z values for y. Can you guys please do it for y also, everyone, on your laptops? Did you get the z values for x and y both? Please reply by yes or no at least. Everyone, please complete this quickly. Everyone, did everyone complete this? Please reply yes or no, guys. Okay, so now see the importance. Now we will come to know the importance, the significance of this, of z-score. As I always tell, don't go with the formula, go with the significance of each parameter. Now calculate this, call for this z values for x, calculate the mean. You will see something interesting. Can you do that, guys? 0, right? That's the importance. Calculate the mean for z values for y. 0, right? So did you understand the beauty? Calculate the sigma, calculate the standard deviation for this quickly, for both z values of x, z values for y. Quickly do that. Calculate standard deviation for these new two columns. The way we have calculated standard deviation for normal x and y, let's do that for z of x and z of y. You will notice something really interesting. Did you calculate standard deviation, guys? Yes, exactly. It will be 1. So for both of them. So what did you understand? For two different scales, x and y, whose mean were so different, whose standard deviation was so different, we have brought down those two different parameters to a same scale, such that their mean is 0 and the standard deviation is 1. So now if you notice, this all the different graphs can be incorporated in one single graph. So the graph which we had earlier with different scales, now we will have something like this. Now you will have something like this. Okay. Okay, there is some problem with this. Just give me a minute. Let me draw it here. Yes. So you will have now all the graphs with same mean. I'm not very good in drawing, but you got the logic, right? You will have all the different normal distributions with same mean and standard deviation now. Did you understand, guys? Yes, it will be 1 and 1. Yes, for both the x and y. Did you understand the significance now of z-score, right? So this is important, guys, so that trying to bring different scales into one normal scale is called standard normal distribution. And now this is important again. If I tell you, if I have a x value of, say, this, on the x-axis we have random variable, right? On the y-axis we have frequency, right? So if you look into this again, that appraisal example or the temperature example or pressure example, the temperature of the 68% of the components will be near to the ambient temperature from, and this is called as one standard deviation. So you know the standard deviation value is 1, right? So mean is 0, which is here. This will be -1, this will be +1. 0, +1, +2, +3, 0, -1, -2 and -3. Okay, So there will be 68% of the components will be lying between -1 and 1. There will be 95% of the components which will be lying from -2 sigma to +2 sigma. There will be 99.7% of the data will be lying between -3 sigma and +3 sigma. Does it make sense, guys? Did you understand this? Because highly frequent components or the temperature which are near to average temperature will be more frequently occurring, right? So that will be lying here, right? So that's the logic, guys. That's the importance. That's the essence of this normal distribution. So if you all might have heard this 6 sigma of very late, right? 6 sigma, people are talking about 6 sigma quality. What do they mean by 6 sigma? That means if we predict or if we do something, the quality of the analysis what we do or anything what we do, that should be with 6 sigma. So if you can understand now, with 3 sigma we have 99.7% of the data lying within 3 sigma about the mean. So for 6 sigma you can imagine what will be the value. It will be 99.99999 something. So you must have heard in your organization follows 6 sigma quality, and this is what they mean by 6 sigma in real life. Yes, so why particularly these values? So it always we can calculate these values. If you want to do that, you can do that on Python, R or Excel, it's up to you. But if you notice, first of all, understand this. What is this normal distribution? No, it's not about a common given values. Yes, it is a common given values, but they have derived these values. How? Let's understand that also. How did they derive? Because I don't want you to just mug up the values, right? As I always tell. This is your normal distribution. In this normal distribution, all your data will be lying, right? So if I ask the probability value, the sum of the probability values will be 1. Yes or no? Because the sum of all the probability should be equal to 1. Yes. So if I give any data, the probability of that data lying between plus or minus 1 sigma would be 68%. Now, how did we come to this value 68%, right? That is your question, right? So tell me, if this is the this normal distribution is 1, the probability for this curve is 1, area under this curve is 1, which is denoted as the probability. If I divide that at the mean, then 0.5 probability will be on the right side, 0.5 probability will be on the left side. 50% of the data will be lying on the left side, 50% of the data will be lying on the right side, right? So if I want to check what is the area under this curve, you know how to calculate the area under this curve? The 68% is denoting the area under this curve. So if you do the calculation, you have to calculate the probability. Okay, you have to calculate the probability. And how to do that? What will be the value of z? You can use integration, yes, but I don't want to get into that. You are rightly said. You can use integration, but I don't want to get into that because that would be a very complicated mathematical topic. Let's understand in a simple English, and then we will see. You guys can do that replicate that in coding. Tell me, what is the z value here at my cursor? 0. What will be the z value at this point? At this point, similarly on the left side, right? Now, what we have to do is, there is something called as z tables in the internet. You can use that, and that z table tells you how much area is covered between 0 to +1 and -1 to 0. See, here it is very simple because we know these values, or these are the very standard values which we have derived. But for example, if we want to find the area between this curve, then it will be difficult, right? So for that we need table. So you can use z table, you can type it on internet and check for that, or you can use Python, or you can use R or Excel to calculate this probabilities value. See, you can do that, but I want to show it practically. So what I will do, I'll just use internet in this case. Okay, is everyone able to see this table? Okay, now for example, for the value of z, say 1. For z equal to 1, what is the probability that we have to check? So this is for negative values. These are the positive values. Look at my cursor, guys. Z equal to 1. I told 1, right? Did I say 1.05 or 1.01? No, I told 1. Z equal to 1 with 0, right? So what is the value? Can everyone please write 0.84134 on the chat box? Okay. Now, what is this value 0.84134? Let's go back to the presentation. So where is z equal to 1? Here. So this at all the left side, all the area which is covered from here, from left side till z equal to 1 will be 84% of the area will be covered on that. Okay, from left side till z equal to 1, the area covered is 84%, right? 0.84134 means 84.134%, right? We have to calculate between -1 and 1, right? Yes or no? So let's go calculate for -1 now. For z equal to -1, the value is 0.15866, right? Now, see what this value denotes for -1. Area covered from left side till z equal to -1. What is z equal to 1 value indicates? Area from left side till z equal to 1. And what do we need to calculate? Area between -1 and 1, right? We want to calculate area between -1 and 1. So, see what we have done, we have calculated till -1, which is this 0.15. We have also calculated till 1, which is 0.84. Now we want to calculate this, right? The intermediate part. So what should we do? We should subtract these two values, right? Yes or no? Yes. So you got the value. So now you understood how did we get this answer? You will get near to 68%. Yes. So now you got the logic, right? It's the significance of z-score is you have this data available to calculate the probability based on z value, because we are converting different normal distributions into standard normal distribution, by which we are calculating the probability. Let's start with this. These are the 4 business movements. Okay, guys. First one is pretty simple. Measure of central tendency, which we have learned, which is mean, right? Second business movement we have already learned, which is measure of dispersion, which is variance. Third business movement is skewness. Okay, so if you notice, we can have the normal distribution slightly skewed like this or slightly skewed like this, right? We can also have this kind of curves, right? So this is where we call that the data is slightly skewed, and this has its own importance, guys. Okay, for example, by this we are telling that if we have, for example, if we have data of the temperature say 0 to 200, and most of the temperature values are lying near to 35-40 degrees, and then remaining are here also, right? So the temperature is not lying exactly at 100. The average temperature is not exactly 100, right? It's near to 35. And most of the data is falling near to 35, right? So that's the reason the graph is something like this. Similarly, you can come up with an example for what data such cases we will have this kind of examples. For example, the vehicle speed is say 0 kmph to 60 kmph. And most of the times we'll be driving the vehicle with 40 kmph, right? And above 40 it will be very rare, right? Because nowadays in India we have a lot of traffic. So most of the people will be driving with 40 or less than 40. So this is how the data looks like, right? So this is called as skewness. And this is how you have to analyze your data. Okay, did you all understand skewness? Similarly, we have fourth business movement, which is kurtosis. So this is also very simple, guys. For kurtosis, if you notice, you have a very symmetric normal distribution. Ideally, it will not be a case, but let's assume this. You have two normal distribution curves, like this and like this. If you notice, the peak thickness is more. That means most of the people, there are so many people which are falling under average, exactly near to average, exactly near to average. In this case, there are few people which are near to the average. Making sense? So now the task for you guys is, see, I told you an example for skewness. You have to come up with an example for kurtosis and tell me what would be the significance of this kurtosis in the analysis. Okay, before going ahead, I want to go back to the second business movement. In second business movement, we have learned variance and standard deviation, right? Similarly, for first business movement, there are other two parameters which you have learned in your school days, mean, median and mode, right? Which is a measure of central tendency. We have all learned this, mean, median and mode. What is mean? Average. What is median? Central value. What is mode? Most frequently occurred value in a series, right? Yes or no, guys? Now tell me, when we already have something called as mean, which is giving the average value, why there is something called as median in the world? See, I told you, no, I will make sure that you understand the significance of the parameters, not the formulas. When there is already mean exist in the world, then why do we have median as a separate central tendency measure? What do you mean by for accuracy? Just imagine guys, right? So just imagine in this case, I give you the data series, say 1, 2, 3, 4, 5. What is the mean and what is the median? Tell me guys. I have given you the data set of 1, 2, 3, 4, 5. What is the mean and what is the median? 3 and 3, right? How do we calculate the median? Put the series in increasing or decreasing order, and then the central value would be the median, right? So now do one thing. The series is 1, 2, 3, 4, 100. 1, 2, 3, 4, 100. Now please calculate mean and median. Median is 3, yes, mean, right? So now just understand in this way. I want to do, for example, MBA. Let's take, I want to do MTech. Let's assume that I already completed MTech, but let's assume that I wanted to do MTech from IITs. Now, in different IITs, they tell that the average package what their students are getting after completing the MTech from their college, let's assume that, only assume, okay? The average package is 22 lakhs per annum, okay? Then what does that mean? The average package is influenced by this value 100, right? But median is not influenced by 3. See, there could be a chance for different university, the mean might be 10 and the median might also be 10 or 11, right? Making sense? So what I'm trying to tell here is you cannot always look at the average value or mean value, right? See, by just looking at the mean value, I think, say if I have two universities, University A and University B. In University A, I have the average package 22 and the median package is 3 lakhs per annum. For University B, the average package is 10 lakhs per annum and the median package is also 10 lakhs per annum. Then which university you will choose now? Tell me. University A or B for your admission? B, right? You cannot choose A because see, in University A is influenced by one of the student who has got very high package. So it's not necessary that we will also get the same package, right? Making sense? So only one of the instances is there with very high package which is influencing your mean. But median is not influenced by these high values. B, this 100 is called as outlier. That means it is out of the range of the data set. It's not following the normal trend of the data set. That means if you notice, all the university tells that this is our average package, please join our college. This is our average package. We are getting this placement of so 20 lakhs, 10 lakhs, please join this package. But have we ever noticed what is the median of that? We never notice the median because mean is always influenced by outlier. And this is your interview question, guys. Mean is always influenced by outlier. Okay, did everyone understand this? Okay, so before going into the next slide, we can take up that next slide in the next session. But before that, I want to show you, this is what you have to work as a challenge. Okay, there are 5 questions you have to work on these challenges. In this average, okay, Naga, you have a question. In this example, even median doesn't guarantee the proper inference. Yes, see, the point is inference will tell you, median will at least tell you that don't take your decision only by looking at the mean. See, what happens if you, by looking at the mean, you might join the University A, right? And then you end up asking, like, once you do the lot of analysis, you will come to know that that mean is influenced by that very high package, right? That's the beauty of this. Mean and median both will help you. See, even alone median can't help you. So both mean and median is helping you how to analyze what decision you should make, right? That's the whole point. So that's the reason I always tell, just don't look at the average values. You should look for average and median both, because averages are influenced by outliers. Okay, so this is a challenge. So you have to work on these 5 questions, guys. Okay, please start working on it. See, here we are not doing simple maths. We are trying to understand the logic behind the math. We are trying to understand the significance, the mathematical intuition, so that this all can be applied from next session when we start with machine learning algorithms, for which we have huge demand in outside market, right? It's not just that for pleticotic Naga, you can have like 3 also, 4 also. You don't have to worry with 2 different variables. Okay, it's not about 2 different variables. You will have the same. First of all, it's not about 2 different variables. You will have the single variable which will be taking different values, right? For example, you have the temperature here on the x-axis. Here you have 0 degree, 10 degree, 20 degree, 30 degree, 40 degree, 50 degree, 60 degree, so on up to 200 degrees, right? Right, different data value. So it's not about 2. It's just an example. Don't worry. So it says that most of the values lie near to this average value at the center. In platykurtic, in leptokurtic, values will lie near to average, but not in comparison to platykurtic, it will be lesser. So you have to come up with an example for this kurtosis. How will this kurtosis be helpful in our analysis? So next section we'll start with machine learning and AI. Okay guys, so I'll take a leave if you don't have any questions. Thank you everyone.